So this is the briefing for the ECE 100 lab number 8, the microcontrollers loop lab. This lab is unusually long in terms of the briefing and probably unusually short in terms of the execution. So I thought that it would be worthwhile to go through the programs that we're going to be using in lab today. Now the first program, lab 08A, should be very familiar to you. This is just bread and butter, what we've been doing so far. Turn pins 2 through 9 to be outputs. And then we're going to go into the loop, which is going to repeat many times, delay 100 milliseconds, turn all the LEDs on one at a time from 2 up to 9, then with a delay in between each, then turn all the LEDs off from 9 down to 2, again with a delay between each of them. And so we're going to get this sort of behavior. It goes up and then down and then up and then down, and that's going to repeat forever. Now although that certainly is fully functional, look at that code. That's not interesting code. There's just so much, like this right here. Is that the best that we can do? No, that's not the best that we can do. The best that we can do is to put that into a loop so that we don't have to constantly be typing these things over and over and over again. So let's look at a loop. Now here we can see this is the main line of code that initiates the loop. It comes in 3 parts. The first part is the thing that's going to initialize the counter variable. In this case, we're going to call it index. We're going to initialize it to 0. The second block, or the second piece here, is going to keep track of when should the loop end. Well, the loop should continue as long as the index is less than or equal to 7. It should end if that's ever not true. So when the index reaches 8, then this loop is going to end. And what should happen at the end of each time through the loop? Well, we should increment that index. So the first time through it'll be 0, then it'll be 1, then 2, 3, 4, 5, 6, 7. We'll come back up here, we'll check and see, oh, it's become 8. Nope, shouldn't execute it another time. So it'll execute a total of 8 times, and index will contain the numbers 0 through 7 for each of those 8 times. You'll notice that that's exactly the same thing that happens down here inside of loop, that we're going to be incrementing the counter each time through the loop. We're going to be able to see that each time we're going to write to a particular LED pen. Now, which LED pen are we going to be writing to? That's controlled by this array up here. So here we have an array. An array is really just like a series of individual integers or a series of individual variables all in a row. So in this case, we're going to have 8 of them, and they're going to contain the numbers 2, 3, 4, 5, 6, 7, 8, and 9. And we can be able to access them by the one name of the entire array, which is LED pens. Now, we can access this first one in C in a quirk. We're going to see that this is going to be numbered 0, and then number 1, 2, 3, 4, 5, 6, and 7. So don't confuse the index number, which starts with 0 and goes up to 7, with the contents. So this is number 2 up to number 9. In the same way that a mailbox has a number on the outside, that would be the 0 through 7, but it could also have mail inside, that would be the numbers 2 through 9. Those are completely different ideas. So if I access LED pens of 0, then I'm going to get this number right here. If I access LED pens of 0, 1, 2, 3, 4, so if I access LED pens of 4, I'm going to get this number right here, and LED pens of 7 will give me this number right here. So notice that when I'm saying LED pens of index, well, the first time through the loop, that's LED pens of 0, which if I scroll back up again is 2. So we're setting pen 2 to be an output. Then the second time through, index contains a 1. LED pens of 1, that's the number 3. LED pens of 2, that's the number 4. LED pens 4, that's the number. LED pens of 3 is the number 5, all the way up to LED pens of 7, which is the number 9. So here's where we're setting them all to be outputs. Here's where we're turning them on one at a time, and here's where we're turning them off one at a time. Now that's better code. That's easier code. It's more dense. We've cut the length of the program almost in half, and it's not nearly as tedious as it had been before. Now, this is a lot of text that describes what I've just told you about. Talk about an analogy to mailboxes. And then very important again to observe, in C, the index of the first array element is 0. You would probably choose 1, and I totally would too. But eventually, we're going to see that having this first element be 0 is actually going to be a good thing. I know it doesn't seem like a good thing right now. So here's more information about the main program itself and how we're writing 1s and 0s. Let's talk a little bit about functions. A function is just simply a piece of code that we're going to break off. We're going to put it in its own sort of block, and then we can call that function anytime that we need to. Here's an example. We have a program here. Well, setup, although we haven't talked about it, setup is actually a function. Loop is a function, but those are always there. So now we have two new functions. We have one called count up, and we have one called count down. And those basically just do the two halves of the job of loop. If I scroll back up again to that previous program, oh, that's going to take a while, so let me go real fast. In this previous program, notice that loop really had two jobs. It counted up, and then it counted down. Well, now we're going to break that into two different functions. We're going to have a function called count up, and we're going to have a function called count down. It's going to do exactly the same tasks as it did before. So what we can do then is we can also add more functions. Oh, one other thing I wanted to mention. If you see this index plus plus, that's just the same thing as index equals index plus 1. Either one of those lines of code will increment the contents of index by 1. And similarly, index minus minus is the same thing as index equals index minus 1. Now we can go crazy with functions. Here we have a count up and down. Well, count up and down really just calls count up, and then it calls count down. And so here you can see the contents of count up, and here's the contents of count down. We have a function called ping pong, which is kind of like count up and down, but I'll let you look at what ping pong does. And then marquee does some other fancy stuff where two lights are lit up at the same time, and they're going very fast up and down the bar graph. So we have different patterns of lights. We can call those different patterns of lights at different times. You can see here that the loop now counts up and down, and then it does ping pong, and then it does marquee. You'll need to go in and change that a little bit to do a little bit more complicated stuff, but for right now, that's enough. The last thing I wanted to show you is that there is this function called random. Now, we don't have to write the random function, but we get to use the random function. We provide what is the highest number that we would like to be able to have, and then we'll get a random number back that goes between 0 and 7. So it goes from 0 up to this number minus 1. And so we're going to light up a random number, a random pen. We're going to delay for 1/10 of a second, then we're going to turn off that random pen. And that's all that random LED does, is it turns on a random LED, waits for 1/10 of a second, and then turns it off. But inside of the main program here called loop, we're going to do that 100 times. So notice that this loop does a task 100 times, and the task that we're doing is calling random LED. So it will call it 100 times, and it will, after it's done that, then it's going to put in an extra long delay of 10 times 1/10 of a second, or a full second. So it's going to sit there for a second and do nothing, just so that we can recognize that loop has in fact finished and is getting ready to begin the next time through the loop. So that's an introduction to sort of what you can do. You should also watch the video that shows a demonstration of these programs, because together I think that those will give you a good idea of exactly what you're capable of doing with this code.